Okay, let's start first with reviewing, and then we'll do the question last. Right? I don't know. Because then it's like, oh, we just reviewed everything. Now let's see if we remember.
Is there a lot of stuff, like, do I write really small?
Let me tell you. I forget what's on here. Yeah, you probably want to write kind of small.
Wait, can I see around?
Sample. Oh. All right, so first let's start with triangle trig. Okay, so if you're trying to find an unknown side length and you have a right triangle, I'm putting this up here because you might not need it. It's kind of like ultimate review, right? Right triangle, solving for unknowns. You can use or you can use the Pythagorean theorem. Don't forget, those are always available to you. But also, I see you guys use them in non-right triangles sometimes. Yeah, I'm truly haunted by this. For people at home, be happy that you're at home. You do not see what's going on. Is it locked? Oh. Okay. If it's not a right triangle, though, you have to use the following formulas.
Oh, okay, you're talking.
In non-right triangles, you are going to use either the law of sines or the law of cosines to solve for unknown. So the law of sines, right, we've got sine A over A is equal to the sine of B over B. Hello, Jason. Would you like to sign in? Thank you.
The doc is in.
And then so we're also going to have the law of cosines. So let's remember that when we are doing law of cosines, chances are the problem is probably in degrees, but it also could be in radians, so just make sure that you are double checking the mode, the correct mode. We usually pick law of cosines for the side across from a known angle, and then you know the other two, right? But you need that side across. And then we usually use law of cosines when you know the side across from one of the angles, you have the angle, and you need the side across from the other angle. Are you guys starting to piece together like the pattern of when you use which one, right?
Yeah.
Okay. What about area of a triangle? Yeah, so use whichever one is easier, right? Sometimes it's 1/2 base times height, and then sometimes it's 1/2 AB sine of C. Just remember that C is the angle included, yes, between A and B, right? So if you have like a triangle and it looks like this and you have A, B, this is the sine of C that you're using, okay?
Is 1/2 base times height only right side?
Yes. She got it. All right, what about, is that it for triangles?
I'd say so. Probably.
Yeah. All right, let's go to circles. Boom. I don't know why I like organized it like this. It's just should just be one big square, but whatever. It's fine. Circles. All right, let's start with the formulas and then we'll talk about them, right? Area equals 1/2 theta r squared. What is this the formula for? Area of a sector. Good job. A sector looks like a pizza slice. Well, I'm sorry. Were you haunting us through the door? Okay. And then we also have another formula that goes with circles, and that is arc length. And that's basically the length of a pizza crust, if you want to think about it like that. Okay. And just remember that both of these formulas, you always need to have your theta in what? Radians. Good job. Okay. Next, let's move on to Pythagorean identities. I'm going to lump the double angle formulas in here as well because these are basically just like the tools that we have to rewrite when we're solving equations, okay? So I've got Pythagorean identities and double angles. So we've got cosine squared theta plus sine squared theta equals 1. This helps us turn one into the other. Do you know what I mean by this helps us turn one into the other? I have sine squared. I'm trying to match in like a show or a prove problem. And I'm like, okay, I'm going to turn this guy into the other one that I need. You can always use this formula. Also, if you're trying to evaluate like the sine of 2a, right? And you happen to have just the cosine of 2a, right? You're going to probably need to turn one into the other using this formula, something like that, okay? So you're going to use this formula to help you turn one thing into the other and try to get something if it's unknown. We also have our double angle formulas. And then we also have these. You have a few to choose from. Okay, so if we ever have angles that are like pi over 2, or let's do it like this. Sine of pi, 3 pi over 2, or 2 pi, right? If you have something that looks like this, these are called the quadrantal angles. When you're evaluating those, you should always sketch the unit circle. And then you don't need to like memorize anything. You can always figure it out from here, right? This point over here on the unit circle is going to be 1 over 0 up. X is cosine, y is sine. Okay? And then you figure out the rotation angle from there. So then you go up pi over 2. This is now pi over 2. This is 0, 1. This is now pi. I'm just like walking you around it like we're in a garden. Oh, yes. This is pi. This one's going to be negative 1, 0. Keep going. This is 3 pi over 2. This is going to be 0, negative 1. Keep going. This is 2 pi, back to where we started. Okay? So you can always sketch the unit circle to help you figure out the quadrantal angles.
It's like, you know how we made those paper plates?
Yeah.
With all like the coordinates? What's an easy way to remember all of those?
To remember the angles or the coordinates? Because the coordinates turn into the common trig ratios chart, right? Those coordinates on the unit circle as we go around. Remember how we made the triangles and then we found out that like, oh, the ratio of the sides is the coordinate on the unit circle.
I think it's the coordinates. I don't remember.
And then the rotation angles, right? You just go to the next irreducible factor of that angle, you know? So,
I don't know how to explain it. Maybe like when sine, like pi over 3, like what is that? Isn't that like a 6?
he's on your common trig ratios chart. So we're gonna get to that. We could do that part now if you want.
Anyway, whatever we're doing on.
Okay, well, but we will definitely get to that. Okay, good question.
I was just asking.
Yes. So topic 3 in your formula booklet. If you guys want to go to your formula booklet right now and go to topic 3, take a look what's in there. We don't really go over it too much because the formulas are in there, but I want you to see what's in there. Like, you should know what shapes and what 3D figures have formulas in your formula booklet. Do you need to borrow one?
No, I was just doing that. I stole a bag from you. You want it back?
Oh, no, you keep that. Yeah, you can give it to your mom for Mother's Day. You can give it to Stevie.
What is Mother's Day?
You don't know Mother's Day?
I'm not sure. I think it's coming up. All right, so in your formula booklet, can you guys tell me what kind of stuff is in there? What do you see? Give me. Yeah, areas, volumes, all that good stuff. So if you ever are being asked to calculate the volume of something and you don't know what the formula is, they're not going to ask you something that isn't in the formula booklet or that you wouldn't already know. So go check the formula booklet. Don't get stressed out. It's probably in there. Okay?
I feel like our
You guys have done
You let me know when it comes back to
I
you.
read the press release.
So they have they have the volume for a rectangular prism, a cylinder, a prism, a right pyramid, a right cone, and a sphere. They also have the surface area of a sphere, curved surface of a cone, cylinder, and the distance formula in 2 dimensions and 3 dimensions. You've seen that crop up in some random spirals throughout the year, right? We've had like 1 or 2 where you're like, oh, the distance formula in 3 dimensions, excuse me. You would just sketch it and then use that formula for the 3 coordinates that it corresponds to. Remember, 3 dimensions, you've got x, y, and then the z coordinate. Okay. Cool, that's for your formula booklet. So, let's talk about sketching angles, okay? Sketching angles. When do you have to sketch an angle? You have to sketch an angle when it is not located on your common trig ratios chart. So let's put the common trig ratios chart on here so that way we can talk about it, right? So, Miranda, is this what you're talking about where you got sine, cosine, tangent?
Is that where we're writing those? Is that
Huh?
where we're writing?
Yeah, sure.
No, I already know what it is. I think it's like, I don't know, I don't know for sure.
Okay. So, always remember, pi over 6 comes first. If you guys get the wrong angle first, you're going to mess up the whole chart, right? So pi over 6 comes first. The way you can remember that is if you divide a piece of pizza between 6 people, they're going to get much smaller slices than if you divide it by 3 people, okay? So the smaller angle comes first. Pi over 6 corresponds to a reference angle of 30, pi over 4 is 45, and pi over 3 is 60, just in case they ask you in degrees, but they usually don't. Okay. So we do 1, 2, 3, 3, 2, 1. If I were you, if I have an extra second during that read time, I would write this ratio chart right at the top of my paper on my formula booklet. So that way I have it there and I'm not wasting like exam time writing it out. Okay? Okay, so you can see the tangent of pi over 6 sometimes like this or sometimes like this. Just be able to recognize it in both forms because sometimes you land on a different form when you solve trig equations, right? This one's 1, and then we have radical 3, okay? So when you are solving a trig equation, you need a reference angle and a sine. Plus or minus. Okay? So if you have the sine of x equals positive rad 3 over 2, you would see that you have a positive. You have to figure out the reference angle using your chart. You would go here, go up to see what the reference angle is, and then you have to do your sketch. Okay? So if you end up with a trig ratio that is not on this chart, so let's say you have something that's like the sine of x equals 4 over 5. You've seen problems like this before, right? 4/5 is nowhere on this chart. If I have something that is not on this chart, I need to do what with it? I need to sketch it, right? And then it'll give you a clue as to what quadrant it terminates in. Is obtuse, something like that. Well, we know that obtuse angle is going to be greater than 90, right? So if I have my little sketch here, would this guy be located in quadrant 1 or quadrant 2? Why haven't I narrowed it down to quadrant 1 or quadrant 2? Because sine's positive. I'm going to go to quadrant 2 because it's obtuse, okay? So you're going to look for your clue here, which is the numbers, the ratio, and then you're going to look for your clue here to figure out what quadrant you're going to be in, okay? Then you isolate the quadrant that you're supposed to be sketching this guy in, and you sketch it like this. Oh, sorry, they use an X. Okay. So, sine is going to be opposite over hypotenuse, right? Oh, yay. Do you remember your Pythagorean triples? Those could be good to remember, so that way it's easy, right? So you got 3, 4, 5. Except careful, in this direction on the x-axis, 3 is going to be negative. Good job. So if I were to be finding, and then the question would be like, find cosine of x. That would be like what you're supposed to be doing. And you'd be like, okay, the cosine of x is going to be adjacent over hypotenuse. Wait, double check. Is cosine supposed to be negative in that quadrant? He is. Yeah, you're right. Good. Okay. So this is when you sketch. You sketch when you have a weird number over here that's not in the chart.
How do you know that it's not in the first quadrant?
Because it said it was obtuse. They're always going to give you a clue that tells you what quadrant it is. Because they could always be in 2 quadrants if they're positive or if they're negative, right? So you got to be like, I need to narrow this down because it can't be in 2, right? You got to figure out which one you're going to sketch it in. They also sometimes are like, comma, x is greater than pi over 2 and less than pi, or something like that. So then what quadrant would that be in? Oh, actually quadrant 2, same quadrant, yeah. Okay, so that could also look like a clue. Okay. Ba, 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 ba. The ambiguous case. You hear that? Alexis does not like this one. Well, where does the ambiguous case arise from? The ambiguous case arises from the fact that sine is positive in 2 quadrants. Okay? So, things to remember about the ambiguous case is we have 2 places where sine is positive. Can I write this as the sine of pi minus theta? Does that make sense? If this is the sine of theta, is that an okay way to refer to them? Wait, what do you know about the sine ratio in quadrant 1 and quadrant 2? It's the same. Therefore, something that they love to ask you about in regards to the ambiguous case is some sort of substitution involving this. They're like, prove that, and then you have to match some structure there. And they want you to see that you can remove the sine of pi minus theta and put in the sine of theta because sines of supplementary angles are congruent. Do you guys remember doing problems like this? Supplementary angles are congruent. Okay. So this guy crops up when you're trying to find an unknown and you use law of sines. Is usually when he crops up. If you have to then decide how many possible triangles, do you guys remember those, right? So you could say like crops up when using law of sines, and you have to determine how many possible triangles. And the way that you would do that is remember that there is a fixed number of degrees in every triangle. It's 180 or pi, depending on whether you're in degrees or radians. And then think about the amount that they give you, right? They said like maybe one of the angles has 45 already. How many possible triangles are there? You'll have to remember that there's already 45, and then consider the case where the unknown angle is the obtuse or acute version, okay? And then you can make your decision from there. I would do a lot of drawing in a problem like that. Make sure that you have everything all written out, okay? What else? We did our common trig ratios chart. Let's do solving trig equations, and then that's the last part for this guy, okay? Solving trig equations. What am I writing? Equations. Okay, so when we're solving trig equations, what is it asking? It's asking you what angle makes this equation true. Don't lose sight of that, okay? So there are a couple of tools available for you to solve trig equations. One of them is u sub of a trig function. This is when you use u substitution for structure. You use these in sneaky quadratics. For example, you would have like cosine squared x plus cosine x plus 5 equals 0. You would let u equal cosine of x. And then, remember, do you need to adjust the interval in this case or no?
Yes.
Ooh, a house divided. You do not need to adjust the interval. Okay. If you are letting the argument of the trig function be your u, that's when you adjust the interval, which leads me to my next tool available to you. This is going to be u sub of the angle, or you can think about it as the argument of the trig function. So you use this anytime you have anything other than a plain old x. So if you have sine of x, do not use. If you have the sine of 1/2 x, use it. If you have the sine of 2x, use it. For example, you could have the cosine of 1/2 x plus 2 equals 1. In a case like this, where you let u equal 1/2 x, you would need to adjust the interval. Let's say it was, oh my gosh, did I just turn off the video? Hang on. No, it's still on there, but it went away. I don't know why. It's hiding. Okay, so let's say the original interval was this, right? You would now need to multiply this whole thing by 1/2. So you have the correct number of solutions. Yep, and then at the end, you got to make sure that you put your answer back in terms of x. Good point. Let's put a little star here that says adjust the interval in this case. Okay. And then let's put Miranda's note. That was good. Don't forget to sub back in for u at the very end. At the very end, you get all of your solutions, and then at the end you turn them back into x's, okay? Sometimes you guys do it too early before you do all the rotations and you don't get all the answers, okay? Are you on the phone?
I'm gonna call the back and see if he can be there. So I'm waiting for it's on hold, so I'm just
What?
There's a noise
it's more
coming
important
from
things to
over
do
there.
than
I know. Naomi's like, I'm on a business call. Can you stop?
President.
Yeah, stop talking.
Naomi is the. I would vote for Naomi for president. For sure. For sure. I'm going to Unit 9. Because remember, like, trig is Unit 4 and Unit 9. Yeah.
What's unit?
So there's more notes?
Yeah. These are quicker, though. I'm sorry.
How quick?
Lots of notes.
Wait, can I see?
What? I kind of lied. So, it's only 2:50. This goes till 3:20. Don't yell at me. Okay.
Don't worry, I'm here for the whole ride.
Yay! Me and Jason. Bye.
Miss Fletcher, can I write myself a note?
Yeah.
I just stated.
indistinguishable. I couldn't tell the difference between that and the real thing.
We're out the next day.
What do I write on the note?
Okay.
You're excused.
So let's talk about all the different things in a trig function, okay? This guy is going to be the amplitude. And when you're given the graph, the way that we find the amplitude is we do max minus min divided by 2. B is the frequency. Frequency is related to period inversely, so it's period equals 2 pi over B. C is the phase shift or the horizontal shift. Sometimes you might need to factor out that B in order to find out what the actual horizontal shift is. Don't forget that.
I'm gonna forget that.
Please don't. And then D is the equation or of the midline. You can also think of it as the vertical shift. Okay. This is the same for tangent, except in tangent, the period is equal to pi over B. Oh, I like the sideways. Look at that. Very aesthetic. See ya. Okay. And then in tangent, just think of like, A is not really an amplitude because it goes from negative infinity to positive infinity. Its range is all real numbers. But you could think about it more as like a stretch. So when there's like a positive number out front and it's like a 5 or something like that, it's going to be steeper. Okay, it follows the same kind of idea as transformations, but... That's what I mean by that. Okay. Okay. So, when you are identifying the period from a graph, you are going to... Did I write? I don't know. I can't read my own handwriting. But what it would look like is you're waiting to see when it completes one fundamental pattern. So when does it return to where it started? So you're going to be like, oh, it returns right to that spot. You see what I mean?
Yup.
Returns to its start / one fundamental pattern. Okay. So once you get your period, right, that's the distance along the x-axis. You take that period, you set it equal to 2 pi over b, and then usually they ask you to find b from there, okay? So it's like this distance becomes your period. Yeah? Okay. Now, things to remember, okay? So sine, when you're thinking of like a sine curve, right? It goes through this, right? And then it goes like this. So sine goes up first. So a lot of times they like to kind of see if you're paying attention. If it goes down first, what do you have? If it goes down first, you have negative sine, okay? Same thing with cosine. Cosine usually starts at the maximum, right? So if it starts at the minimum, what do you have?
Oh, it's negative.
Yes.
I'm slaying this.
Yes. All right. Yeah, that looks good. Okay, don't forget that trig derivatives are inherent chains. When you are integrating, do use substitution. When taking the derivative, multiply by the derivative of the inside, okay? Why do we do use substitution when you're taking the derivative of a trig function? Because that helps you make sure you get the constant out front correct. Although a lot of you might start seeing patterns, right? If you have like e to the 3x, or no, let's pick a nice number, e to the 6x, right? Are you guys starting to see the pattern of like what the constant will come out front if you're trying to do, if you're trying to integrate, right? But if you're not sure on that, you should always use u sub for integrals, and don't forget to multiply by the derivative of the inside, because all trig are chains. Okay. The derivative of sine is cosine. The derivative of cosine is negative sine. Don't forget my song. Yeah. Therefore, if you needed to write that down in order to remember what the integrals are, you could do that. Or if you want, you can just look on your formula booklet. They're also in your formula booklet, okay? Special relationships save time. Don't forget. That the sine of x is equal to the sine of pi minus x. So, you know, sometimes they might say, how many times does this graph cross the sine of pi minus x? And it's a no calculator question. You're like, how am I supposed to know that? Oh, that's right. The sine of x is just the sine of pi minus x because it's just a shift. So I can just kind of superimpose that and think about it like that. Do you know what I mean? That was kind of a weird explanation. But if you have paper one and you're trying to make a sketch, special relationships can save you time. Tangent is undefined sometimes, so just make sure you know what a tangent graph looks like, right? It's the one that has all the asymptotes. Yeah? Okay. What else? Graphing by hand. When you graph by hand, first, you're going to get your train tracks. Where do the train tracks come from? Not in a...
Oh, the max, the midpoint.
Yeah, not in a sine or cosine. So you would get the midline, count up for the amplitude, count down for the amplitude, right? So that could be thought of as like the max is equal to, let's say the midline is D, like from our example over here, right? You see how D is the shift. So midline is D. So our amplitude can be thought of as D plus A. And then down here it could be D minus A, if you want to think about it like that. Then you got to find your period. Period equals 2 pi over b. If you're graphing something by hand, you probably have the b in the equation and you have to use the b, sub it in, and then find out what the period is from there, right? And then 3, you're going to fill in your quarter points. You know what I mean by quarter points? And remember that the graphs are symmetric, right? So if they just give you the distance from like the max to the min, you know that if you double that, that's your period, right? So max, min, zeros. And then you're going to base your sketch off your graph type. So if it's sine, sine starts passing through the origin. If it's cosine, cosine starts at the max, right? And then make sure you after 4 comes 5. Make sure after you do that, that you stop at the interval. So they're going to give you like a specific interval to graph over. Okay, and then if they don't, put arrows on the end. Yay, that's it. Okay, let's do some problems. Who's got problems?
Oh, I didn't get it all. I'm not.
Jason, you're going to fail now.
I'm gonna fail now.
Here, we'll freeze it for you while I scroll. How about that?
Thank you.
Shall we just doing 5? Building questions 5 and 6, or we also gonna do?
We're going to do 5 and 6 and then the one for 9. But I think we might finish early today. Look at us.
Yes.
Yeah.
Done.
Done. There he is.
I'm back.
Okay. I wanted to review bearings with you because I know they're Mackenzie's favorite. So here we go. Is that the one who just said I hate bearings, or was it Miranda? Yes. We can all rally around a common enemy. I love that. Okay.
Can we
So,
assassinate them?
sure.
Yay.
The following diagram shows 3 cities, A, B, and C. I actually took away the diagram so you could practice drawing it just in case you would have to draw it on the test. Okay, so.
You better not.
All right. So city B is 70 kilometers from A. So A down to B. That's how you're always going to set these up because it helps you kind of like envision the drawing. You know what I mean? So if you have A, right, you start with your A point. You draw an arrow coming out at 90 degrees, right? A down to B is on a bearing of 130. So A down to B, so it's going to be like a little obtuse. It's going to kind of go down like this. And this is 70 kilometers. Okay. What would it look like if the bearing was acute? It would be like going up, right? City C is 40 kilometers from city B, so B down to C on a bearing of 75, okay? So B down to C on a bearing of 75 means it's going to come up a little bit from there, right? So it's going to be like this a little bit, yeah? Okay. And then it's 40 kilometers. Okay. So then now it says, is that everything from our diagram? Yeah. Find CBA. CBA. So remember in bearings, I guess I'll give you guys some notes over here, okay? All norths are parallel. No. All norths are parallel. So that helps you use like the laws of a transversal from geometry to help you solve unknowns. My pen is charging, so I'm going to write this part on the board. Maybe you want to think about it? Yeah. Yes. Jason, would you like to walk us through how you knew it was 125?
I gotta do all, okay.
Actually, I think it charges pretty quick. I might be alive. Hold on. So I'm like, okay, all norths are parallel, so I'm going to kind of extend this. I'm trying to find CBA. I need like that little piece right there. I see that like, ooh, if I made a transversal, right, this is congruent to this. So if I just find the supplement of 130, it's going to be 50. And I'm like, oh, if that's 50, then this is 50. So then I'm just going to add them together. Okay. Heh. Isn't it weird how they do angles different than in geometry? They like put the arrow over it. B.
Do we have to, like, on the test, write the CBA equals 125, or can we just circle the answer?
I feel like it's always better to write CBA
Oh,
because then you know that whoever's grading it knows that you know where the answer is and it's circled. But like, I would assume the people who are grading the tests are trying to look for the right answer. So like, if it was there, they're not going to be like, ugh. But maybe that guy's having a really bad day. So like, I don't know. I would probably just write it all out and make it clear. You know.
That's not paper, right? That's a stupid question. That's not paper, right?
Yeah, you have like an answer booklet for the long answers, and then the short answers are in the booklet.
Okay.
Okay, so find the distance from A to C. What do you know about A to C? I could just connect it, right?
oh, it's a triangle.
Yes.
Oh, you could do the thing. The thing.
I now have this angle, and that's the across from here, right? Can you be more specific? Law of cosines, right? Yeah.
C squared.
Yeah. So I need the side across from a known angle, so I'm going to do, let's label it AC, okay? And then A is 70 squared plus 40 squared. Someone do this in their calculator so you can tell me the answer.
Ooh, I don't have one.
No, not no calculator at all. Make sure you're in degrees.
Nope. We're all men.
That's what I do.
No, I always forget, like, especially in the box, like, I forget that I have, like, calculator, so I start solving at my paper, I'm like, I don't know how to do this. And
I do that.
really forgot that I have my
Wait,
calculator.
and solve
Yeah. I think that's a pretty classic feeling in the beginning. Or probably even still now.
I would try to solve it by hand, and if I can't, then I'm like, oh, I just.
No, sometimes I
Yeah.
just completely forget that I have my calculator, so I just leave the problem.
I'm guilty of that. I think on the key for the one from class today where it was like g of 2a equals whatever, I solved it by hand and then I was like, oh, I could have just done this in the calculator. And I was like, whatever.
98.5.
What'd you get, 98.5? Yes, that's what I got. Okay. But yeah, don't be a hero. Remember, you don't get extra points for doing stuff by hand, right? If you can do it in the calculator, just do it in the calculator. Okay, if you wanted to travel from city A directly to city C, find the bearing you would need to travel. So if I'm going from city A to directly to city C, so I'm like going, hold on, let me, oh, my picture's like a little funky. It looks like it's 90, but we can't assume it's 90. Do you see what I mean? Yeah. So what do we need to figure out then? Well, I know that this whole thing is 130, right? If only I could get this little nugget right there. Then I would know because I could just subtract it, right? How could I find that little missing piece there?
Oh, the shrine, no?
Love sign.
Yeah.
Oh, that one.
So I've got the sine of 125 is across from 98.5, and that's going to be equal to the sine of c, and then I'm going to have to subtract at the end to get the other one, but that's fine. Or wait, I could just do 40 over the thing. I have that one.
Yeah.
Yeah.
Oh.
Okay, I was wondering what you were doing.
Yeah, I was like,
Who knows? Who's to say? All right, let me know what you guys get.
Look, I drew Doug.
What?
As Doug.
Oh my God. You guys love Doug today.
He is. He was the best.
Let me know what you guys get.
19.4.
Yes. Okay. So remember, that's us doing 130 minus that little piece, right?
Yeah.
So then what would you get? 111-ish? Yeah. Yes. Find the area enclosed by connecting the three cities in a triangle ABC. All right. We already did that to figure out the other thing. So I would get 1/2, and then I would get 70. This is 98.5, and I just found this angle here to be
111.
yes.
You got it.
Oh wait, I could also just work with nice numbers and just do that though. You see what I mean?
Ooh.
I could do 1/2.
Or give me the area.
Yeah.
We could do
I could just work with
70.
nice numbers and do all that. Yeah.
We could do that.
Yeah. Okay. That's just a calculator question.
Go on, calculator, people. Should I give him Yeezys?
What's that?
You don't know what Yeezys are?
Oh, I thought you said, should I make them easy? I was like, what?
No.
Oh.
No, you give him
Draw,
Yeezys.
yes, draw him some easy.
1146.8.
Yes. Round to 3 sig fakes because it doesn't say.
1150.
Good job.
That's so weird.
Awesome. I know, so weird. Okay, here, we got a little trig problem. Next. Given that the cosine of x equals 3/4. Hold on. I see a weird ratio. This is 3/4. He is not on my common trig ratios chart. What should I do with him? Sketch. And then what's my clue? I'm from 0 to pi over 2. What quadrant am I in? Yay.
Uh-huh.
Just the interval because it's sine of 4x.
We will get to that. You're not going to adjust the interval. You're going to,
Just the x.
like, I'll show you in a second. Let's sketch it first, okay? So I'm in Q1. This is x, and then I have adjacent over hypotenuse. Okay, this isn't a nice little 3, 4, 5, so I got to do Pythagorean theorem, right? Ew, that's a very sad 3. Hold on. Let's call this y. Okay, I have it. Yes. Just double check the signs. Oh, good. We're in quadrant 1. Everything's positive. No problemo. Okay, now this triangle is used to find all the trig ratios that I need in order to find the sine of 4x, okay? So let's match the structure here, right? I know that when I have the sine of 2x, what happens when I write it out? A 2 comes out front, and then I cut the angle in half, right? Okay. So if I know that that's a structure I follow when I'm doubling an angle, and it's sine, right? What would happen with the sine of 4x? Well, I put a 2 out front, and then I cut the angle in half, right? And then, now I have like a bunch of stuff I have to deal with, right? So I now have the sine of 4x. I have to expand this guy out. He becomes 2 times 2 sine x cosine x, right? And what about the cosine of 2x? Which one do you guys want to use?
The sine squared.
Sure.
Don't question me.
Okay, so now look on this thing. This is going to give you all the inputs that you need, right? What do you need for inputs in this formula here to figure out what the sine of 4x is? What do you need?
Sine x.
You need sine x, and what else do you need?
Cos x. But we already-
Cosine x. Good job.
We had that already.
Yeah, they gave it to us. Yay.
It's right there.
So now we got sine 4x equals 4 times, and then sometimes kids, they like put in the ratio in sine. The sine of x is equal to the ratio, right? So like sine of x is equal to opposite over hypotenuse. I feel like we're all guilty of that at one point or another, yeah?
I'm never guilty of that.
Okay. And then cosine of x is 3 over 4 times. Okay, there's going to be 1 minus 2. And then sine squared is going to be rad 7 over 4 squared. And then now it's just some algebra. Boop, boop, boop.
I'm confused on the second part where you did 2 sine of 2x times cosine of 2x.
2 sine 2x times cosine x. Okay, so when we first broke it down, right, that's the structure. What happens? We have this, and we just get plain old, and then a 2 comes out front. So if we're matching that same structure for a quadruple angle, right,
Then we just multiply.
we put a 2 out front, we halved the inside, and then we had to further break it down because we don't have sine 2x. We have sine x. We have cosine x, right? So if you keep doing this, you got these cancel, you get rad 7 over 1 times 3 over 4 times, and then in here you would have 7 over 16, 2 of those, these cross reduce, minus, you would end up getting 7 over 8, so let's put this as 8 over 8, so now you have, oh, I'm frozen. Maybe I can write over here though. Sorry, it's in a weird spot, but I'm frozen. So now I got 3 rad 7, and it won't let me erase. Okay. 3 rad 7 over 4 times, and then in here I've got 8 minus 7, which is going to be 1 over 8. So now I've got 3 rad 7 over 32. That sounds really weird. Is that the right answer?
I got that
Woo!
somewhat. I had it 20 times wrong. I can't times.
I can't times. Is that an ailment that you would bring to Dr. Greg?
Yes.
All right. We are doing our last problem now, and then we are free. Oh, yes. We're like so on time, guys. I'm proud. All right. Here we go.
You're welcome.
Shh, the room is packed. You guys just can't see. All right. Let's look at daily question number 9. We're just doing number 9. 10 is integrals. Okay. It says let f of x equal sine x minus rad 3 cosine x from 0 to 2 pi. The following diagram shows a graph of f. The curve crosses the x-axis at A and C and has a maximum at point B. excuse me, find the exact coordinates of A and C. Okay, so it looks like A and C are the what? The zeros, right? So let's go ahead and use that to find out what they are. So I've got the equation, which is going to be the sine of x minus rad 3 cosine x. And let's set it equal to 0, okay? Do you guys remember what I told you when you have a singular power of sine, a singular power of cosine, and they're split up? It's usually going to turn into what? Tangent, right? Because it's not being squared, can't turn one thing into the other, right?
Yeah.
So if I want tangent, I need to leave sine over here. Okay, I'm going to add rad 3 cosine x. Oh. And then I'm going to divide both sides by cosine of x.
Ooh.
And I get tan equals radical 3. So common trig ratios chart, right? We all have it written down already. So what's it going to be? Pi over 3. Good job. So my reference angle is going to be pi over 3. Okay, now that we have our reference angle, we need to consider